Hello everyone, I am Soham from Teacher Circle. I am your chemistry mentor. Today I will teach you the basic thing of chemistry, that is atomic structure. So let's start the video. So to know about the atomic structure, we have to know the atomic number. What is an atomic number? So basically, an atomic number will be is equal to the number of electrons or is equal to the number of protons. So let's take an element X. Then the number of then the atomic number will be the number of protons or the number of electrons. So as all of you know that the atomic number starts from 1, that is hydrogen, helium, lithium, beryllium, boron, and so on. So let's now I will give you an example. Hydrogen, the atomic number is 1. So the number of proton is equal to 1 and the number of electron will also is equal to 1. So atomic number is denoted here. If an element is H and the atomic number will be written over here. After that, there is another thing, that is mass number. What is a mass number? So for that element X, if the atomic number of that element is 1, then the mass number is 0. And how I am proving that? That a mass number is equal to the atomic number plus the number of neutrons. For an atomic number, I have said you earlier that it is equal to the number of protons or is equal to the number of neutrons. But for the mass number, that will be equal to the atomic number plus the number of neutrons. Mass number is equal to number of protons or atomic number plus the number of neutrons. After knowing the atomic number and mass number, I will teach you the electronic configuration of an element and how to calculate it. So we know that there are 7 orbits. What are those? K cell, L cell, M cell, N cell, O cell, P cell and Q cell. So there are basically 7 cells or 7 orbits for an electronic configuration. So if it is a nucleus where proton and neutron is present, so therefore the electrons revolve around the nucleus, the center of that atom. So for how to calculate it, we have to know first. There is a very easy formula to calculate the number of electrons maximized in a fixed orbit, that is 2n square. And how we will calculate it? So for a K cell, that is the first cell, so 2 into 1 square, that is 2 into 1 is equal to 2. Now for third cell, that is M cell, how many maximum number of electrons will stay there? By putting here 2 into 3 square, so 2 into 9, that is equal to 18. So maximum number of electrons can stay at M cell, that is 18. We have to know first before calculating the electronic configuration of an element. Now for hydrogen, I will show you also the orbit. Hydrogen we know that the atomic number of hydrogen is 1. So number of proton is equal to 1 and number of neutron is equal to 0. And number of electrons is only 1, as the number of proton and number of the electrons are same. So how we will write the electronic configuration? For K cell it is 1, L cell it is 0. So basically we will write the electronic configuration like this, and number of proton is equal to 1. So therefore atomic number is equal to 1. Now let's take another example, that is oxygen. We know the atomic number of oxygen is 8. So how will show the electronic configuration of oxygen? Let's draw the cell. So the number of, as the atomic number of the oxygen is 8, so number of proton is 8. Now the electrons, These are the cells of electrons. So for a fast cell, for K cell, number of electrons maximum is 2. No more than that electrons will stay here. After that, in L cell, what are the remaining? If K cell occupied 2, then remaining number of electrons will be 6. That is 1, 2, 3, 4, 5, 6. So how will write? For K cell it is 2 and for L cell it is equal to 6. So number of protons is equal to 8. Atomic number is equal to 8. So basically this is the way of writing the electronic configuration of an element. So let's take another example, that is calcium. The atomic number of calcium is 20 and the mass number is 40. So for nucleus of that atom, the number of protons is equal to 20 and number of neutrons, that will be is equal to 20. And how I will calculate it? So how we will calculate the number of neutrons? So that will be is equal to the mass number minus atomic number. So what is the mass number basically here? That is equal to 40 minus atomic number, that is equal to 20. So number of neutrons will be is equal to 20. Okay, so I have right here 20. Now the draw the cells of electrons. So for first cell that will be is equal to 2. For second cell that will be is equal to 8. Now for another cell, that is M cell, that will be again is equal to 8. From 2n square formula, what we have learned, that maximum number of electrons that can be stay here in M cell, that will be is equal to 18. But from the modern periodic table and modern formula, it has been calculated that the formula of calculating the number of electrons or for drawing any electronic configuration of that element, that will be is equal to 2 for first cell, and then we will follow the octet rule, that is 8. So for that octet rule, the every number of electronic cell will be maximum number, that will be 8. That is the from octet rule. Okay, so I hope I could make you understand. Therefore for M cell I have draw 8 electrons and remaining number of electrons is 2. So for N cell the number of that 2 electrons will fit there. Okay, so this is basically the electronic configuration and this is the drawing of cells of the calcium. So how we will calculate the electronic configuration over here? For K cell L, M, N, O. For K cell it is, we know that 2, L cell 8, M cell 8, and for N cell that is equal to 2. So atomic number 20 or the number of electrons is equal to 20. So this is the electronic configuration of the element calcium. Okay, so from here I just want to add a point, that what is that octet rule. From octet rule it has been proved that number of electrons for an electronic configuration of that element or for drawing any electronic configuration of that element, the number of maximum electrons can stay there, that is 8. Okay, and why we have chosen the octet rule? Because that the noble gases, what are those noble gases? Helium, neon, argon, krypton, xenon. Okay, why we have chosen them as a noble gas? Because they are the most stable gas. Why? When a cell is been fulfilled with the number of electrons, or rather we could say that when a cell having, so for a neon, I will just make you understand by drawing that electronic configuration. For neon, the atomic number we know that 10. Okay, so for K cell is equal to 2 and for L cell is equal to 8. So when a element having the electronic configuration, or rather you could say the cell is fulfilled with the number of electrons, then it is the most stable gases. Why it is the most stable gases? Because when an electron is having fulfilled with electrons, then it has no tendency of losing or gaining. Therefore we could say it's a stable gases. Therefore we chosen the octet rule as the 8. Okay, another example of noble gas, that is argon, having atomic number 18. So what will be the electronic configuration of argon? For K cell, L cell, M cell and N cell, that will be is equal to 2. This 2 is from the duplet rule, and for octet rule the maximum number of electrons can stay there is 8. Okay, so when you will calculate this number of total number of electrons, that will be is equal to the 18. So from octet rule it has been proved that number of electrons maximum can stay here in a single fixed orbit, that is 8. There are two very important things in our daily life, that is we take common salt and how common salt is prepared. Now I will teach you that very important thing. So for common salt the formula is NaCl. Okay, how these two elements combining each other and form a compound. So sodium and chlorine. Okay, these are two other respective elements. So what is the atomic number of sodium? That is equal to 11, and for chlorine that is equal to 17. So for chlorine for sodium 2, 8 and 1, and for chlorine that is equal to 2, 8 and 7. Okay, element is considered as stable with their nearest noble gases configuration or inert gas configuration. So for sodium, what is the nearest noble gases configuration? That is neon, that is 10. Okay, so it and the other element, that is argon, which is far away from the sodium. But for chlorine it is very nearest to argon. Why? Because it is 17 and argon is 18. Okay, so it will be better for sodium if he loses one electron, and for chlorine if he gain one electron. Then for sodium he will get the configuration of neon if he loses one electron, and if chlorine is adding one electron, then it will get the configuration of argon. So both of them will get stable. Okay, after knowing the electronic configuration, now we'll come to the bonding. What is a bonding? Okay, as we all know that how a bond is been formed in a chemical reaction with when two or more other elements are combining each other by sharing or by gaining or by losing, then a bonding is formed with them. Okay, there are two types of bonding. What are those? One is electrovalent bond, another is covalent bond. I will teach you now the electrovalent bond. For sodium, the outermost shell having the number of electrons is 1, and for chlorine the outermost shell having the number of electrons, that is equal to 7. And for sodium, if he loses one electron, okay, then he will get the configuration of the nearest noble gases, that is neon. Okay, so if it loses one electron, then it will 10, so it will get the nearest configuration of neon. And chlorine is gaining one electron, that is chlorine, the number of electrons will be 18, so it will get the nearest configuration of argon. So both of them will now get as a stable gases. Okay, so both of them will be considered as stable, and therefore they will combine each other and form NaCl. Okay, the common salt. So this type of bonding is called as electrovalent bond. Now I will teach you another bonding, that is covalent bond. What is a covalent bond? That they will mutually share each other. Here either he will lose or gain, but for a covalent bond, here what will happen? That is they will mutually share each other of electrons. Let's take an example. That number of for a nitrogen, number of electrons present is 2 and 5. Total number of electron is 7. Okay, so 2. So for a N2 bond, the outermost shell having the number of electrons is 5. So if both of these mutually share each other, so first take an example that for sharing, if he shares the number of electrons, that is 3, then this will get fulfilled and this will get the nearest inert gas configuration. But when again it will be 2, so there will not be fulfilled. So again, if this nitrogen is again shared, these 3 electrons. So again it will be fulfilled. That means both of them, when they mutually share each other, they will form a covalent bond. What that covalent bond? They will get the nearest stable gas configuration. So today my class was up to this. If you like this video, please hit like and subscribe our channel. And if you have any doubt, then comment us below on comment section. For getting new updates, please hit on bell icon